So, Sana, Parth, Aryahi, Bhavish, Anika, and Vishali. Are you guys able to hear me okay?
Yeah.
Can you see my finger dancing on the board? Okay, all the corners covered? Wonderful.
Yeah.
So, we are starting a new unit called, what is the name of the unit? You guys remember? I kind of forgot. And I have all the reasons to forget because I am getting old. So this unit is about polynomial factorization. Okay. So how do you factorize polynomials? What are the key elements of it? What are the things that you need to take into consideration? We'll talk about all that and we'll do that practice on that. But before I get started, my simple question to you all is, what do you mean by polynomial? What is a polynomial? Give me a very lame description of it because I'm not very intelligent. Tell me in very simple terms. What do you guys know about polynomial? Vishali, Bhavish, Anika, Aryahi, Parth, Sana, anybody? Yes, Aryahi, tell me.
Polynomial is like an expression with like variables, coefficients.
Okay. Anybody else? Sanvi, Ipsha? You've not heard the term polynomial? Okay, interesting. That makes me happy. I have something to teach. Okay, how about Bhavish? Have you heard this term better?
I think I really got forgot.
Okay, how about Dishali?
I think I know like some of it and how to.
Parth? You know what is polynomial? Can you describe it in simplest possible way? Sana, any thoughts around it? No, I was asking Sana also.
What?
I was asking, what is your understanding of a polynomial? What is a polynomial? If you have to describe that to me, and assuming I'm a 5th grader, how would you explain that to me? Okay, don't worry. Sanvita also has joined. So Sanvita, we are learning polynomial factorization today, and as soon as I came across the word polynomial, I was struggling. Wanted to know if somebody in the class can explain me what is a polynomial. Now everybody in the class is scared. The teacher himself doesn't know what is a polynomial. How would he teach? Okay, let's get started. Yes, Anna. Go ahead.
Is a polynomial like multiple like terms or like multiple things together? Like multiple numbers and variables?
Wait, is it like a vector?
I'm sorry, Vita?
Is it like a lighter, like a constant variable, or like another?
Yeah, I'm getting information bits and pieces. Let me try packaging it for you guys to be able to relate to it. Okay. Samita, you're trying to say something?
Yeah, I was gonna say it's an algebraic expression with like variables and coefficients.
Okay. All right. So let's start. Let's create a story out of it. First of all, I heard the term expression from one of you. So I will use that as a base to get started. Now, since the parents are here, I don't have the option of cracking dad jokes, but I'll still try my best.
Okay.
So let's see, you all come to the class. And I keep smiling, keep showing my sad face, keep saying something, but don't teach anything. That is just expression, there is no outcome. You'll see me smile, you'll see my sad face, but there is no outcome. That is what is exactly expression. So if I'm talking about 4x squared plus 7x, this is just an expression, there is no outcome. How the outcome comes into play? When you put an equal to sign. Now, if I put a 15 here, what it means is you have a variable named x. 4 times the x square value plus 7 times of x will give you an outcome of 15. So that is the difference, right? Same thing. If I'm teaching, there's an outcome for you guys to take away. If I'm just smiling the whole class, that is an expression. This is expression, this is equation. When you have an equal to sign, that is an equation. That part is okay now? Now you can let's focus on expression for now. So now what you see here is you have a 4x squared and you have a 7x. And they are separated by a plus sign here. This is called a separator. You can have a plus sign here, you can have a minus sign here. Plus and minus, these are called separators. So here you are seeing one thing here, another thing here, and separated by a plus or a minus sign. Yes, sir, you're saying something?
Can you repeat that? I couldn't hear you properly.
Don't worry, I'll repeat myself so many times that you'll get tired. Okay, and everybody be on mute because you have to only unmute yourself when you are answering something. So here you are seeing two things. One is 4x squared and you have a 7x. Two things, they are separated by this plus sign. These are called terms. This is one term, this is second term. Now if I give you another example, 7x cubed minus 2x squared plus 7, why I'm putting 7 over and over again. 8y minus 17z. This is still an expression. What you are seeing here is you have one minus sign, one plus sign and one minus sign. These three are your separators. Hi Vasundhara. These are your separators and this will help you count how many terms you have. So this is one term, this is another term, this is third term and this is fourth term. And apparently in this expression you see three variables x, y and z. Doesn't matter. You don't count the terms based on the number of variables you're dealing with. You count the terms based on how many separators you have. Is that making sense to everybody? Arya, is that making sense to you? Hasandi? Ipso? So, we just learned how to count, which you guys learned 10 years ago. I'm still re-emphasizing that. How do you count a term in an expression? So here, this is an expression, this is an expression. Even if I say 7, today is the day of 7. Okay. 15x to the power 10. How many terms do you see here? Only one term. There is no separator here. Okay. So we just learned how to count the terms. All these three are expressions because there is no outcome. There is no equal to sign in any of them. Yeah. So these are expressions. This is expression, this is expression, and this is expression as well. If you are looking at this expression, you are seeing one term and one more term. Two terms. Here when you are looking at it, one term, two terms, third term, fourth term. Here when you see there is only one term. Regardless of the power, even if I put 200, x to the power 200, I'm still talking about only one term because there is no separator. Are we clear about that? So, is everybody with me? Dishali, Vasundhara, Sanvita, Nanya, everybody? Sana? Okay. So we just learned how to count the number of terms in any expression. Okay? Yes, but that's right. So we just learned how to count. This expression has two terms, this expression has four terms, this expression has only one term. So number of the power or the exponent of any term doesn't really matter when it comes to counting them. We'll only look at the number of separators we have and based on that we'll derive how many terms we are dealing with in the expression. Yeah? Yes, Parth. You have to be literally shout at me, okay? I cannot hear you. Be louder. No, so see that's what I was saying. You don't have to worry about something to the power 200 or 2000, okay? Doesn't matter. What I'm trying to convey here to you all is, if you don't have the separator plus or minus, there is no second term, there is only one term. Even if I put, I'm literally getting very funny here. Even if I'm putting a power of I'm still talking about only one term because there is no separator. That's what I was trying to say. Okay. Yeah. So I just taught you guys how to count the terms. So let me take out the fun out of it and be serious. So we have three expressions that we are seeing on the board. This one has two terms, this one has four terms, this one has only one term. Let me put some sequence to it so that it becomes more like a storyline for you guys. So this is the first expression 15x squared, second expression 4x squared plus 7x, third expression 7x cubed minus 2x squared plus 8y minus 17z. This expression has only one term. I'm not sure if you guys have heard about monorails. Mono is a Greek word used for representing one. This is called monomial. Any expression with only one term is called monomial expression. Here, when you see there are two terms, and you would have heard the term bi-weekly, bi-monthly, bi-yearly. That by, by is by, by is by when you say by, and bi is representing number 2. Again, this is borrowed from Greek. So this is called binomial because you have two terms, binomial expression. If I have three terms, trinomial. If I have four terms, quadrinomial. 5 terms, pentanomial. 6 terms, hexanomial. Heptanomial, octanomial. I am not trying to flex here. They are simple things. If only one term, monomial expression. If you have more than one, polynomial expression. Poly stands for many. So that's a demarcation. Whatever I said with respect to binomial, trinomial, quadrinomial, those are right terms, but certainly you guys don't want to stress out about it. Okay? So you have only two categorization, monomial expression and polynomial expression. Are we all clear about it? If you have to tell a story to anybody who is a 5th grader, would you be able to do so? That's what I was expecting from you guys actually when I asked this. If you know it, you should be able to explain that in a very decoded form, in a very easy way to explain to anybody. Yeah. I'm waiting to hear a confident yes from everybody. If there is any doubt, I would not mind going back to it again. Everybody comfortable? Bhavish, Dishali, Anika, Sangita, Vasundhara, Samri, Ipsha, okay? All okay? And if you guys feel thirsty, let me know. I can get you guys some water bottles. So, we just learned how do we count terms, what is the difference between monomial and polynomial expressions. Okay. So, and we also saw what is how much difference it makes with respect to number of variables or the power on any variable. Simple takeaway is, if you have an expression, you will only look at the separators, which is plus and minus sign only. Okay. If let's say if I say 6x cube into x5 into y cube, is this a monomial expression or a polynomial expression? Monomial? Sure. Ariani?
I think it's a
Monomial. Okay. Sana, Sanvita, you agree with Ariyahi or you want to counter her? Monomial? You guys don't want to fight? Okay, good. So, net, one thing, no matter how many variables, how many powers you're dealing with, but you will only look for these separators, plus and minus, to count your number of terms. Now, we are going to talk about polynomial factorization. Meaning, if I have a polynomial, let's say, x squared plus 6x plus 9. I'm trying to factorize this. What do I mean by that? I mean, that's all about this unit, okay? So that's what I'm asking. If somebody says we learned what is polynomial, okay, there is no doubt now, conceptually. So, if somebody says you have to factorize this polynomial, what do we mean by that? What are we trying to achieve? And some of you would be thinking that no, this gentleman has not taught anything and is asking questions. I'm just trying to understand what is cooking up in your mind right now so that I can try relating to it. Yes, Samrita, tell me.
Like, you kind of break it down
Break it down like how?
into smaller pieces.
It's already broken to 3 pieces.
Well, yeah, but like, when like they're multiplied together, they get like the original expression.
Okay. Yes, Samrita, tell me.
Greatest common factor.
You have to shout at me, okay? My ears are 49 years old.
Greatest common factor.
Common factor, okay. Dishali?
But isn't
Yes, Bhavish, go ahead.
isn't that the lowest factor you could go because they're all different terms? So how are we supposed to like make it lower?
Okay, that's an opinion. How about Dishali?
I feel like it's we should simplify it further.
Okay, Sana?
When we factor, we do like x plus something times x plus something, right?
Exactly, that's the magical word that I was wanting to hear. Okay, thank you. So basically when you say factorize, right, your goal is to break it into something form. Okay? Eventually what will happen is, in the future state, you will see that somebody says, okay, find out x cube plus 4x squared minus 7x divided by x plus 2 into x minus 3. I mean, I'm just making it up. But when you have to solve for this or simplify this, that is where this concept of factorizing it. Let's say if I have this, if I can factorize this into something, let's say x plus 2 into x minus 9. Again, I have not done any calculation, I'm just making it up. Then what will happen is, I will say, since I see something common in the numerator and denominator, I can knock them off. This is my simplified form of this expression. Yeah. So factorizing helps you simplify things, and we'll see the application of that. Okay, right now I'm just giving you the prelude of what exactly we are heading towards. Yes, Ariel.
Sorry, I raised it by accident.
It's okay. So basically, without going deeper into it or without breaking our head further into it, by factorization we mean that you have an expression and you are trying to break it into something. Or if you are talking about an expression with a polynomial with multiple powers, higher powers, something into something maybe. Okay? And then you look at the common components, you will simplify that. So factorizing means you are breaking into smaller pieces or into factors, right? And factor is something that you would have heard. If I have 6, what are the factors of 6? You will say 1 into 6 or 2 into 3. These are the factors, correct? Am I being too kiddish here with the factor thing that you would have learned long time ago? Yes, Ariel.
Sir, can you repeat that?
I'm saying by factorization we mean we break into something form. Like if somebody says find out the factors of 6, you will say 1 into 6 or 2 into 3. That means 1, 2, 3 and 6 are the factors of 6. That's what you will say, right? I was just trying to relate it to that concept. Now, so you can factorize things, meaning you have anything, be it a monomial, polynomial, you are trying to factorize it into smaller pieces. Okay, let's say if I talk about 8x to the power 9, do you guys think that you can factorize it? Can you guys factorize this 8x to the power 9? Anything of your choice, I don't mind.
No.
I'm sorry, Rudra?
Yes, I think you can do it.
Yeah.
You just hit down.
You can?
Just break down the numbers, just like factorize into many terms.
Yeah. Okay. Does everybody agree to that? You can factorize it?
Yes.
Anika and Vasundhara has been very quiet today. Are you guys with me? Okay, if sir, no doubt. So let's do one thing. I have picked up a few problems relating to this topic, and that I would want you guys to just see what it feels like when we have to solve a problem relating to the factorization, basics of factorization before we go into polynomial factorization detail. So I have a question. The question says, find the missing factor b that makes the equality true. So I have minus 35x to the power 6 equals minus 5x squared times b. So we have been asked to find out what is the value of b. Okay. We have minus 35 times x to the power 6 equals minus 5x squared times b. So we have been asked to find out the missing factor b. What is this b? So something into something gets you this. So you have to find out this one. Can you just play with this one and tell me what the value of b would be? I want to see how much of these things are there in your muscle memory before I give it a shot. Get your hands dirty, see my hands. My hands are always dirty. Yes or no?
Is it 7x to the power of 4?
If you have solved it, I have no other choice but to agree. But I have not solved it yet. But so I will reserve that as an option for now, unless I check myself. Yes or yeah?
Can we repeat the full equation?
It's minus 35 times x to the power 6 equals minus 5x squared times b. We have to find out the value of b.
Well, I got 7x power to the 4.
Okay. How about Sanvi, Ipsa? Thinking? I'm sorry, sir?
7x to the power of 3.
One more time.
7x to the power of 3.
3. Okay, we'll come to that. Vasundhara, Anika, Dishali, what do you think? What is that you got? Yes or yeah?
I also got 7x to the power of 4.
Okay, Samvita?
Yeah, I got 7x to the power of 4.
Dishali?
7x to the power of 4.
Okay. But what's happening? Still working on it? Okay. So again, one thing for all the kids who have not gotten tortured by me enough is be ready to make mistakes, okay? Making mistakes while doing it is okay. What happens is you will say, okay, no, I don't know, I might go wrong. Even if you don't know how to solve it, still try solving it and you will figure out where exactly you are getting stuck, okay? And I'll show you, when I'm solving a problem, I'm writing a story actually. I would want you guys to learn that art of writing a story while solving a problem. So that you would know at what chapter of the story you got wrong. Okay, Sanita, you're saying something more or you're just kept it raised? Okay.
No, I just forgot to put it down.
Okay, how about Vasundhara? Vasundhara not telling me what she got. Ananya? How about Myra? Yes, Ananya, tell me. Tell me, but I cannot hear you. Okay, interesting fact. Myra, who is my daughter, she's in the class, but she's joining from another room. All right, Myra, I asked you to come to the classroom. You did not come. That's okay, but next time I would want to see you here. So let me solve this in a very easy way, and most of you have got it right. Okay, since I have not covered exponents yet in the class, I will not use the exponent concept, okay? I will do that in the layman's way, okay? Which is what aligns with my style of doing things. So here we have minus 5x square times b equals this. We are trying to find out the value of b. What I will do is I will flip this equation right in the way that is easy for me to read. So if a equals b, that means b equals a also. That's what I'm going to do. So minus 5x squared equals minus 35 x to the power 6. So what I want is, I want to know what is the value of b. That means everything that is here goes to other side of equal to sign. Yeah. So b times, here is a multiplication. When I make it cross the border, multiplication becomes division. So it becomes minus 35 x to the power 6 divided by the whole thing coming in the denominator. Everybody okay with this? So here, this and this you can knock off. Now you have 35 into x to the power 6. I will write x 6 times. I have 1, 2, 3, 4, 5, 6 x here, and I have 5 x squared, that is x into x. So far okay? Now fun time. I call it tic-tac-toe. When I have something common, the numerator and denominator, we go back to our childhood days and we say tic-tac-toe. So this one and this one tic-tac-toe. Then this one and this one tic-tac-toe. 35 I can write as 7 into 5. So this 5 and this 5 also tic-tac-toe. What we have is 7. And then 1x, 2x, 3x and 4x. X into x into x into x. 4 times x. That is equal to x to the power of 4. Did that match with the way you guys were thinking about it, or I did something out of the world? I'm sorry, Vita? You can understand this? Yeah? So see, the clue lies in getting your hands dirty. Ifra, did this make sense to you?
A little bit, yeah.
A little bit? I want to be 100%. No, I'm just, see, again, when I'm asking this question to you guys, I'm not trying to put any other child on the spot. My goal is to make sure that whatever I'm explaining is reaching everybody, okay? Teaching and reaching, rhyming words, right? If I'm teaching, it should be reaching you all, okay? If it did not, I can repeat it, okay? So let me do it one more time. I have this equals this. For the sake of convenience, I wrote it in the flipped way. So A equals B, so B equals A. That's what I've done here. Now I have B times minus 5x squared equal to 35x to the power 6. So B times this. What I need is, what is the value of B? That's what I'm trying to find out. That means I'll only keep B on the one side, everything else moves across the border. Border equal to, yeah? So I move this guy across the border, across equal to sign. So when you move it across this one, there is a butterfly. If it's here on the top, it comes down. If it's at the bottom on this side of equal to, it goes above. So when you see this butterfly, this is coming down. So 35 minus 35x to the power 6 divided by 5x to the power 2. And this 35 I can break into 7 to 5. X to the power 6 means nothing but x into x 6 times. Yeah? And then same way 5x squared is 5 times x into x. Now I'm just playing with this. I'm not doing anything fancy. I'm doing tic-tac-toe. Whatever I see common, I'm knocking it off. Make sure that I'm not doing tic-tac-toe here and here. That will be a crime, not a mistake. Okay? So knocking off 1x here and 1x here, 1x here, 1x here. Then I'm left with 1, 2, 3, 4 of x, which is x to the power 4, and then this 7. Did that make sense to everybody? Ifsa is better now? Yeah? Okay. Vasundhara, Anika, Ananya, everybody okay? Alright. Mara okay?
Yes.
Okay. Alright. Now I have one more question. So right now, we are dealing with what? We are dealing with monomial factorization, because if you look at this side, you have only one term. This side also only one term. Right now, we saw that, okay, this can be factorized into this, but we didn't know what is this. So that's what we found out. So eventually you are doing monomial factorization, and we'll do polynomial factorization also after we are more comfortable with what we're doing right now. Okay? Everybody okay so far? Okay. Let's pick one more problem. So when I create problems, when I make up problems, that might get a little harder. So just to keep your grade levels or the level of question that you guys will come across, I pick those questions mostly from Khan Academy, because that is where you will find those questions being more relevant rather than being any hypothetical question that is difficult to digest. So let's look at the next problem. I have one more problem where I have a rectangle. This is 2x squared. This is given it as 18x cubed. This is width. Now the question says the rectangle below as in above here. The rectangle has an area of 18x cubed. This is the area of the rectangle. 18x cubed square meters and a length of 2x square meters. What is the width of the rectangle? Is everybody okay with the question? Did you guys hear the question completely? Sana, Sanvita, Haryahi, Vasundhara, everybody? Yes, Haryahi.
Can you repeat it one more time?
Is that your request as well, Sana?
No, I have an answer.
Okay, that is quick. Let me repeat it for everybody's benefit and then I'll come to you. Okay? The question says, the rectangle that you see on the board has an area of 18x cubed square meters and the length of 2x square meters. What is the width of the rectangle? So Sana, what was your answer, sir?
9x.
Okay. I am not confirming yet, but I'll trust that as an option. Yes, Parth, tell me what is that you are sharing? See, yes,
I got 9x.
you also got 9x. Okay, Dishali, just tell me the answer. Tell me what you got. Whether it's correct or not, that will check any which way. 9x. Okay, Dishali, same.
I got 9x.
Sanvita,
I got 9x.
9x. I too got 9x.
9x. Aryahi,
I got 9x.
okay. Alright. So here, this question is looking way too easy for you guys, right? It was like not something that is exciting enough. So you all know how to find out the area of a rectangle, length times width. This is the width that you have to find out. This is the length that is given to you. And this is the area that is also given. So that length times width, 2x squared times width equals 18x cubed, which is the area given. And this is square meter, this is meter, this is meter. So we have to find out this one. That means if I want to find out width, I will make everything move to other side, which is 18x cubed, and this is multiplication here, will become a division here. So all of you who are not familiar with the tic-tac-toe that I was doing, let's do it one more time. 18 I can break into 2 into 9. And then this x cube is x into x into x. 2x squared is 2 times x into x. Fun time. This one and this one tic-tac-toe, this x and this x tic-tac-toe, this x and this x tic-tac-toe. 9 times x. Everybody got the right answer? Now, since we have some new kids in the class and some kids who have been with me for some time, there is one concept, one very annoying theme that I want to re-emphasize, and I am pretty sure Aryahi, Vasundhara, Sanvita must be guessing what I am heading towards. That is called, I had derived this technique for you guys. I call it RAN. And all of you who have any exposure to track and field, you would know who gets the medal in the race depends on who ran the best. Okay? Who wins the medal in the race depends on who ran the best. Now, what this RAN stands for? R is for read, A stands for analyze, and N stands for Nike. What does Nike say? Just do it. That's the slogan of Nike, right? Here I'm using it for everybody's benefit, saying if you have a problem to solve, this is your technique for solving it. Read the question a couple of times, that makes the question easier to you. Then you analyze, put your thoughts together. Okay, I know this is what this question is asking for. This is how I'm going to approach. These are the formulas I'm going to use. So you are making a blueprint. Read, make your plan, and then just do it. In summary, if you got any problem to solve, don't assume or conclude that this is a difficult problem or easy problem. There is no difficult problem. All problems are easy, we make them difficult. If you apply this technique, you will, by reading it a couple of times, it will become easier to you. Then you start thinking about it. Let's say if you have not learned how to solve a quadratic equation, then obviously you cannot do much about it. But I'm assuming that we all know the basic concepts, and then we have to apply this technique for solving it effectively. So read the question a couple of times, then you make your plan, and then you try solving it. Because every problem that we have, you can solve in probably 4 different ways. If you have to choose the right way of solving it, and that is where this analysis step helps you nail it down to the right technique, which will help you solve it faster and without making mistakes. So this is a recommendation that I have built for you guys. All my kids who have been with me for 2.5 years, they have heard this probably 100 times from me. All because I'm wanting to insist that when you're trying to solve the problem, always go in a methodical way. Read the problem, analyze it, and then you try doing it. Because in an exam-like scenario where you are hard pressed for time, you take a wrong path, spend 20 minutes, then you realize, oh, I made a wrong choice. Redo it again. That 20 minutes that you lost will make sure that you miss 4 more questions and your score comes down. So that's why this technique will help. I will not repeat this unless I get another new student like Sanvi today. But yeah, I'll keep on repeating it because it will make sure that you get used to this way of doing things. Now, so let's do a quick recap of what we have done so far before I move on. First thing is we just learned the differentiation between what is an expression and equation. And then when it comes to expression, what are different types of expression, right? From monomial to binomial to trinomial, and then we said, okay, no, let's not worry about it. There are 2 types only. Monomial expression, meaning only one term. Polynomial expression, where you have more than one term. And your criteria for counting the number of terms is based on how many separators you have, basically plus or minus sign. And then we said, okay, fine. We are heading towards polynomial factorization, but before we do that, we looked at some of the examples of monomial factorization. How do you break a monomial into two parts? A factorization is nothing but break into smaller pieces. Yeah. Now we are going to polynomial factorization. But before we do that, there are 2 key elements that we want to learn. One is called algebraic identities, and second one is called exponents. Where, in your syllabus, when you see, you will find these 2 as 2 different units. But before I try solving polynomial expression, I want to make sure that you guys are familiar with these 2. Obviously we'll spend a lot of extensive time on these 2 units separately, but the basic concepts from these 2 units should be recalled before we jump on to solving a polynomial expression. Okay? Just to give you an example, if I'm trying to factorize a polynomial expression like x squared plus 16x plus 64, I'm trying to convert this into something. Or x square minus 36 if I'm trying to factorize this polynomial. You need to be well versed with something called algebraic identities. And these are essentially three formulas that we need to be well aware of. Let's see if anybody in the class knows about these formulas. Does anybody remember what is a plus b whole square equals? Yes, Ariel.
I know what they are, but I forgot the name, like what it's supposed to be.
That's where I will get you guys tired of seeing the same thing over and over again. How about you, Beta?
I think you've mentioned it before, but I don't remember.
Have you come across this? A plus b whole square. I'm just trying to break it down and see how much it is. Have you heard about, yes, anybody? Vasundhara, Sana, Samvita, anybody? Part, Bhavish. If I have to find out what is the value of a plus b whole square, how much is that equal to? Myra, Nishani, anybody? No? This equals a square plus 2ab plus b square. This equals a square minus 2ab plus b square. And this equals a plus b times a minus b. Okay? Now, one thing that I hate to do is giving formula to the kids, say, okay, this is a formula, memorize it, and your life will be easy. It's not the case. If I'm giving you guys any formula like what I'm showing you right now, I first decode that formula, I explain the breakdown of that before I ask the kids to use it. Now, let's look at it. Samhita, did you not remember this, Samhita? I thought you would be remembering it.
No, I've done this one before, but like I just forget what we used it for.
Oh, okay. So, a plus b whole square equals a square plus 2ab plus b square. How? Why? These are the very powerful words that we should use very often. A plus b whole square equals a plus b whole square equals a square plus 2ab plus b square. Sana, have you come across this beta before?
Me?
Not really? Okay.
I mean, yeah, I have.
You have come across this? Okay. So then it will be a repeat telecast for you, but it's okay. Math is about doing things over and over again to become more familiar. So a plus b whole square equals a square plus 2ab plus b square. How is what we will see now. This is equals a plus b times a plus b. Correct? If I have x square, that is x into x. If I have y square, that is y into y. So if I have a plus b whole square, that means a plus b times a plus b. Yeah? And a plus b times a plus b. What does it mean? If I, let's see, if I'm saying 15 into 5. Okay? What does it mean? 15 I can write as 10 plus 5, right? Into 5. Yeah? Can I do that? 15 into 5, if I'm trying to find out, I can say 15 equals 10 plus 5. The whole thing in bracket times 5. Or I can break it down. So look at this. I have a plus b into a plus b. Let's say this is my 5, okay? And this is 15. So I split this into 10 plus 5. What will happen is, this will become 5 into 10. Oh, let's not do this here. So what will happen here is, it will become 5 into 10 plus 5 into 5. This is called distributive property. When you are multiplying something with something and you have a plus or minus here, you can break it into two pieces like this. So let me not give this example here. Let's go straight on to this one. When I have a plus b times this thing, so what it would mean is a times a plus b plus b times a plus b. Correct? Is this digestible so far? Part, Vishali, Bhavish. Now? Yeah? Vasundhara? Anika? Everybody okay? Are you guys okay with this one? Ifsha, Sanvi? Okay? Yeah. So now simple thing. I'm just breaking it down. A times A plus B, that means this times this and this times this, and I have a plus sign here. So this A times A is nothing but A squared plus, I have a plus sign, so I put a plus. A times B is nothing but AB. Similarly here B times A or B times A and A times B are the same thing. It just, no, I'm just flipping it. So it becomes AB plus B times B is nothing but B squared. What you see here, A squared plus 1AB, one more AB, that is equal to 2AB. If this is watermelon, 1 plus 1, 2 watermelons. That's what you see here, plus B squared. So this is the formula I was talking about. A plus B whole square is nothing but A square plus 2AB plus B square. Okay? And I'm giving you guys one assignment. If I have A minus B whole square, this will be A square minus 2AB plus B square. And you can explore it by yourself also. A minus B whole square, somebody is talking about that. I'm essentially talking about A minus B times A minus B. That's it. And your breakdown will be the same thing. This times the whole thing, then this times the whole thing. And what you will get is this. What you can memorize, like the way I have memorized this for the last 35 years is, I mean, I studied this 35 years ago. And I started teaching 2 years ago. So, due to the 33 years of gap, I could have forgotten this very easily. But one thing I kept in my mind that, okay, if I have plus square and minus square, the only difference comes in this one. Everything else is the same. A square plus B square is common. If I'm talking about A plus B whole square, this one is plus. If I'm talking about A minus B whole square, this is a minus. That's it. That's my shortcut or a dirty method to remember this formula. That's it. And I had the confidence that, okay, any given day if I have to find out or correct myself, I can break it down and reaffirm that if I'm memorizing it right or not. Yeah. So Sanita, Disali, Parth, Haryahi, Mara, everybody okay? Bhavish, Sarvi and Ifsa, okay? Now, the third formula that I was talking about was A squared minus B squared equals A plus B times A minus B. It is no different. Same thing. How you can prove it? Same thing you can do here also. Look at it. You start from here. So you are trying to find out A plus B times A minus B. Is this equal to this? Let's see it. If I have this whole thing, that means A times A minus B plus B times A minus B. Correct? This is not a Facebook post where you have to give a like or dislike, okay? But you still have to affirm, acknowledge that yes, I'm reaching you guys, okay? Yeah? So here, I'm just breaking it down, just trying to make sure that I wrap my head around this one to be convinced that this thing is leading to this value only. Yeah? So now I'm breaking the brackets open. So A times A is A squared, A times B is AB, and I have a minus sign here. So nothing here means a plus sign, so plus into minus gives me a minus. Similarly here, B times A is AB, but here this is plus and nothing but means a plus. So BA or AB the same thing. And plus into minus gives me a minus, B squared. What do I see? 1 minus and 1 plus cancelling out each other. Yeah. So this is not my formula. This is a formula that you can prove 100 times if you want to. These three formulas are called algebraic identities. A plus B whole square equals A square plus B square plus 2AB. A minus B whole square equals A square minus 2AB plus B square. And A square minus B square equal to A plus B times A minus B. Is there a need to memorize it? No. Practice is enough so that it becomes part of your muscle memory. Now, why are we spending so much time on this one? I know school is starting tomorrow, but my work started today. After having a long, hectic day, why am I spending so much time on these formulas? What is the motivation for doing it? Let's look at it. This unit is all about polynomial factorization. Meaning, I have a polynomial, I'm trying to break it into something form. Okay? Let's say now I have x squared minus 49. I'm trying to factorize this. This is a polynomial because I have one term and one more term. Okay? X squared minus 49 doesn't look like fitting with this formula, but this is an option. What is, if I have to compare, x is equal to a. Is this a square? Yes. I have a square minus b square kind of scenario, and what we saw in the formula was this equals a plus b times a minus b. So when you have a situation like this, you have to factorize it. By using this algebraic identity, you could relate it immediately. Does it make sense to everybody? Anika, Riyahi, Myra, Sana, Sanvita. Okay. Now, I picked up the easy problem for myself, and I'll make your life horrible by giving you a difficult problem. Yeah? This is the problem of dealing with a bad teacher. X squared minus 12x plus 36. Factorize it. Everybody got the question right? Parth, Samrita, Anika, Nanya, Dishali, everybody, right? Bhavish. So I'm asking you guys to factorize this one. X squared minus 12x plus 36. When I say factorize, I'm saying some in the form of something into something. And you guys have exactly 5 minutes before the class gets over, so I would assume that you guys can do it in 2 minutes so that I can give my speech towards the end of the class. Yes, Parth. Little louder. Tell me what the answer is. X minus 6 to the power 2. Okay. Let's see what else we are hearing from everybody else. Myra, what did you get? Working on it? Still solving it. Ayahi, Vasundhara, Sanvita. Sana, what did you get, Buddha?
I got x minus 6 times x minus 6.
Okay.
I got
Yeah.
X minus 6 power 2.
Okay. Sanvita?
Yeah, I got x minus 6 in parentheses squared.
Okay. Ariyahi?
I got x minus 6 squared.
Dishali? Same?
I got x minus 6 whole squared.
Yeah. So I think everybody got the same answer. How about you guys?
Stuck on one part.
Okay. How about you, Buddha?
X minus 6 squared.
X minus 6 squared. Make sure that your square is always outside the parentheses, otherwise it will lead to confusion. Okay, here. Everybody is simple. It's simple, okay? Okay. When I say simple, we'll try making it simple. Now what I have is x squared minus 12x plus 36. These are the three formulas, the algebraic identities we have just learned. A plus b whole squared, a minus b whole squared, a squared minus b squared. And these are my easy pickings because if I'm able to map my polynomial with any of these, then I can do it real quick. So let's start with the elimination technique. There are three formulas. A square minus b square equals a plus b into a minus b. So basically, here we have three terms. So I'm not going to look at this guy at all. Here I have a minus. The a plus b whole square is all positive. I'm not going to look at this also. The only option that I would lean on could be this one, depending on how trustworthy it is. So let's look at it. A minus b whole square equals a square minus 2ab plus b square. So I need a square, which is my x. Is this a square? Yes, I see that. Plus 6 square. So I have a square and I have b square. This is my a, this is my b. Is this 2ab? Looks like. So this is my a square, this is my b square, 2ab. Perfect. This is my nothing but x minus 6 whole square scenario. Now if you go back to the most horrible thing that I was talking about. You are not jumping here. You are starting from this. When you look at this, read this, okay, x square minus 12x plus 36. That is when your brain starts processing this. And then you start analyzing, okay, which one I'm going to lean towards? I'm going to not look at these two formulas. Only possibility is this one. Okay, is it a squared? Is this b squared? Yes, this is squared. So this is my a, this is my b. Is this 2ab? Yes. So you have already evaluated all your possible options and then you did this calculation. This calculation would not take more than 30 seconds when you do it with your speed. If you do it with my speed, you might take 2 minutes. But you guys are faster than me. You will do it much faster. Your whole effort goes in decoding the option that you want to go for. Once you have done that, this is cakewalk. Yeah? Am I overstating this or you guys are agreeing to what I said? Yeah? Alright. So, we just looked at some of the basic concepts of what is a polynomial, what is the difference between different types of polynomial versus monomial, what do we mean by terms, what do we mean by, how do we differentiate different types or different elements of a polynomial. And then we looked at what do we mean by factorization. We looked at some sample problems on monomial factorization. And then we just looked at these algebraic identities which can help us with factorization. Does it mean this is the end of the world? No. You might have a situation like x squared plus 8x plus 7. Can you use these identities? I'm just giving you guys some food for thought, okay? Is this a perfect square? No. I'm not able to apply this one. This is anyways having a negative term. I don't have a negative term. So I can look at only this is an option. But my problem is that this is not a perfect square. There will be other ways of doing it. Net, what I'm saying is, this is your one stop. You have a destination to reach. This is your first stop. First thing you will do is check if it's matching with any of those identities. If it doesn't, we'll explore other options. That's what we'll talk about in the coming classes. And I will take a pause here. Whatever we did in the class today, did that make sense to all of you, or I was just teaching myself? Or convincing myself that I'm a great teacher? I'm sorry, Vita? Okay? Alright. Did that make sense to you? Feedback from parents. Was I making sense?
Yeah.
Okay, good. Good. So that's why okay, so we are good with the class. I'll let you guys go. Enjoy the rest of the evening and best of luck for the school starting tomorrow. Alright? Bye bye. Have fun.
When are we gonna start the next unit?
I'm sorry, Vita?
When are we gonna have tomorrow?
I'm sorry, Vita.
When are we
Yep. Alright, bye bye.
Thank